Hello to everyone who has found themselves here today and wants to learn a little bit about physics, biology, and math. So, is math bigger than the human mind, or is the mind more than a machine? This has been debated on by many philosophers and physicists and different types of scientists. But the main guy who's really been talking about this is Roger Penrose. So I put one of his publications right here, his book, The Emperor's Mind, and also some papers that have talked about what he has to say about consciousness and how it is not computable. So, as usual, I've given you some literature to look at. If you want to dive deeper, then I'll go in this presentation. But let's give a summary to begin. A system like Penrose tiling, which is shown here, can follow strict deterministic rules for placing each rhombus next, and that is the structure of the one you're seeing here. It's a rhombus tiling, yet still be non-computable. So this can't be computed. There's no algorithm to work this out. Because there is no algorithm that can always decide in advance whether a given tiling configuration like this one will successfully extend across the plane. So, the way our consciousness and really the way that all matter in the universe comes together might work in a similar mechanism, which makes it deterministic but not predictable. So, what is predicting the way these tilings unfold? And in the universe, I think it might be consciousness itself. It might be choices that are being made. And in previous videos, I explained how space-time might do this in 3 dimensions with a dynamic dodecahedral fractal framework, and how that can create different emergent structures at different scales. So all my videos are kind of connected through structure and frameworks and morphology in biology. So if you want to dive deeper into that, you can look at my previous videos. But to continue, let's start off with some background from 100 years ago. There are true statements in mathematics that can never be proven, not because we haven't found the proof yet, but because no system can ever prove them. So what does that mean? Is mathematics too big for the human mind, or is the human mind something more than a machine? So 100 years ago, this scientist Kurt Gödel said that either mathematics is too big for the human mind or the human mind is more than a machine. And he was one of the pioneers in the role of computation in biology and morphology. He was the pioneer of morphology, so he's really one of my biggest heroes, and it's good to read about him. He's an interesting guy. So the limits of math. Like I said, in the 1930s, a mathematician named Kurt Gödel proved something shocking, now called Gödel's incompleteness theorem. He showed that in any system powerful enough to describe arithmetic, there will always be true statements that cannot be proven within that system. Let that think in. Let that sink in. Sorry. No matter how advanced your math is, there are truths that can escape it. So mathematics isn't just a fixed structure, it's more like an infinite landscape, one that no single map can fully capture. So let's explain Gödel's incompleteness theorem more. It shows that in any sufficiently powerful formal system built on fixed axioms, and it's shown here in this little diagram, and axioms are just true statements that can be said about mathematics. There will always be truths that cannot be proven within that system alone. meaning even something as intuitively obvious as 2 plus 3 equals 3 plus 2 ultimately depends on unprovable underlying assumptions, like the properties of equality and addition, that the axioms themselves cannot fully justify from within. So it's a very simple explanation and a simple figure to try to understand what it's talking about. Because you can basically always go deeper into the subject to things that the axioms cannot prove. So is the mind just a machine? Some, like Roger Penrose, argue that humans can see the truth of certain Gödel statements. If that's true, then the human mind might not be just an algorithm, because any algorithm is like a fixed system. And Gödel already showed us fixed systems have limits. But there's a problem. Humans make mistakes. We forget things. We rely on intuition that can be wrong. So are we really beyond machines or just very complex ones? And you can see that in Penrose's three world philosophy, there are three worlds we kind of exist in. The Platonic mathematical world that we can imagine how math works, the physical world where things are actually happening in, and then the world of consciousness where our imagination and our intuition comes from. But all of these three worlds exist in reality. They just don't seem to always be coherent and coherent with each other. And there, even though there's ways that you can use different parts of of reality to still get to the same truths, as Penrose is describing, even though the axioms in math can't prove some things logically, our imagination and our intuition can prove things because we can relate it to things we see in reality and then use our imagination to understand how that relates to other things in our reality. So our mind has a way of going beyond math because we're actually coupled to reality, unlike the Platonic mathematical world in a lot of senses. So the fractal solution, which I talked about this in a lot of my previous videos, as I said earlier, so you can look at that if you want. What if both sides are missing something? What if the mind is a machine but not a fixed one? Think of it like a recursive system, a system that can rewrite itself. And there is math to a recursive system. You can see formula right here, where the solution to the formula goes back into the original formula. So it creates a feedback loop. That's why it's recursive. So this is where ideas from fractal geometry and recursion come in. And this recursion formula is what can create fractal geometry, because you can understand how if the solution keeps on getting put back into the formula, you would have repeated geometry if you keep on going through that loop. A fractal is never finished. It keeps unfolding, revealing new emergent structure at every scale. Now imagine this: mathematics, an infinite fractal of truths. The human mind, a recursive system exploring that fractal. Every time we hit a limit, we don't stop. We expand the system, we create new axioms, new frameworks, new perspectives. We don't escape Gödel's limits, we move beyond them by changing the game. And that's really what I'm trying to do with this YouTube channel, is to create new frameworks for thinking so we can understand and potentiate the technology that we're using. I really like this picture right here because it explains the stream of consciousness. that the stream of consciousness explores the mind's inner workings with fleeting ideas, emotions, impressions, memories, and sensations blending in fluid, a fluid created by liquid-liquid phase separation, associative passages that can change abruptly. So I really liked this picture because I think it visually shows you what's going on and it gives you something to read while also putting fluid in there to remind us how important water is to life and how important water is to create a framework for information for life through things like liquid-liquid phase separation, which can compartmentalize our ideas even down to the molecular level and be fluid enough so that we can change them and associate the new things we see with our whole brain. And you can go back to previous videos if you want more on liquid-liquid phase separation. So let's talk about coevolution of mind and math. Instead of math is too big or the mind is more than a machine, there's a third possibility. They are co-evolving systems. The mind builds mathematics, and mathematics reshapes the mind. This is studied in fields like cognitive science, where thinking itself is seen as dynamic and adaptive. You are not a static system, you are a process. So, just by the act of thinking, you can change how your brain is structured, which will then change how you see the world and change your thinking. So this is a recursive process happening every day, all the time. So let's give a simple example using birds and butterflies. So you have butterflies that mimic other butterflies like monarchs that can't be eaten by birds. So then you have this feedback loop of the monarchs changing to not look like these mimics, the mimics changing to look like the monarchs, and then the birds trying to figure out what's going on in reality to know what butterflies they can eat and what butterflies will kill them if they eat it. So coevolution between monarch butterfly and birds where toxicity, warning, coloration, and learned avoidance refine each other over time, creates a mutual shaping feedback loop. The relationship between the human mind and mathematics similarly evolves, with cognitive structures giving rise to mathematical systems that in turn reshape how the mind perceives, abstracts, and understands reality. So, in the same way that a bird is trying to figure out what butterflies to eat, and then that butterfly is changing, which will eventually change how the bird's brain is structured, our mind is working the same way, where our thoughts can literally change how our mind is made up, and that's going to change how we interpret things and how we think, which just continues in that recursive loop. So it's happening, this mechanism of consciousness is happening everywhere in biology, which again, you can look back in my previous videos to understand the mechanism. So in conclusion, Gödel didn't prove that math is broken, he proved something deeper. Truth is always bigger than any system that tries to contain it. And the human mind, it's not powerful because it knows everything, it's powerful because it can keep transforming itself to reach what it doesn't yet understand. So the secret to transforming your mind, to transform your body, is to understand reality better so that you can do the right things to put your body in the right position for success. So always try to be thinking and evolving your ideas. So the take home is that maybe the real answer is this: mathematics is infinite, the mind is finite, but the mind has something incredible: the ability to grow recursively into the infinite. And that might be the most powerful system of all, because we have the choice to what we're going to produce in the future. And if we're smart about it, it's only going to get better. So you have a good one, and I'll see you later.